at some point you're just up against too much. So we need a new process. And that process was powder metallurgy. You take the molten steel, and instead of pouring it into a ingot mold, a solid ingot mold, you take the solid steel and you drop it through what we call an atomizer. And there's gas that solidifies the droplets. So individual little droplets get solidified instead of the big ingot mold. Now you're just solidifying tiny little droplets. So you end up with less segregation in the product, because now you're, instead of solidifying something that's 14 or 15 or 18 inches across, you're solidifying something that's at a microscopic level. So with the small particles solidifying very quickly, and once you take the powder product that you have, then you take that powder and you sort it, you sift it, you put it into what we call a can, and put it under vacuum, you seal the can, and then you put it in what's called a HIP, or a hot isostatic press. And that basically condenses that product and consolidates it into a solid product that you can then treat like a normal steel ingot. From there forward, you can forge it, you can roll it, and produce product from it. So what's that look like? So basically, here's the powder. It looks like what you would guess. It's a powder, and there's small particles in there. So basically, what you're getting here is a small particle. So you can consider this an individual ingot, as opposed to the large ingot that you would get in pouring liquid metal. And in fact, if you actually do a chemical analysis on the particles, they're basically all the same chemistry. So each one of those particles is a small ingot with exactly the same chemistry, or close to the exact chemistry. So what's the result of that? And I think probably a lot of you have probably seen these photos before. If you've spent any time around the industry, you've probably seen this photo, or at least a version of it. And the difference is immediate. I mean, this picture sold more powder metal than anything I could put together. And this basically shows you, in essence, what a grade of D2 tool steel looks like, coming from a conventional ingot and coming out of a powder metal product. So basically, you can tell that now you have uniform carbide distribution. You have a smaller grain size, and certainly from a quality standpoint, this has a lot more consistency than a conventional product coming out of a tool steel ingot. So what's this really mean? What this really meant was that the powder metal industry, and I really have to name Crucible as the powder metal person over these years. Obviously there's some in Europe, but they really pushed forward a lot of these developments, and what you could do now is use higher alloyed steels.